Then is to look at the amphoteric nature of aluminium hydroxide, which hopefully you can see we can write like that, or alternatively we can write it like this. Okay, and it's sometimes easier to think about it written like this one in order to think about its amphoteric nature. So amphoteric basically means it will react with either an acid or it will react with a base. And if I go back to, it's a bit of a mess here. Do you know what? If I go back to this here, which we looked at earlier, this is the point at which we've got aluminium hydroxide. I'll just highlight a few bits for you. So we've got 1, 2, 3 waters, and we have 1, 2, 3 hydroxides. So this is basically aluminium with 3 waters, 3 hydroxides, and now it has no charge. And because it has no charge, it is insoluble. Okay, and this is that white precipitate that we get of aluminium hydroxide. Amphoteric means it will react with either an acid or it will react with a base. So if I kind of just talk about it reacting with an acid first of all, it's kind of the opposite of what we did in the last lesson. If I then react this with an acid, I'm basically putting a H plus here, which means a lone pair there will then form a bond with that, which then puts the water back, which, if you think about it now, it's got 4 waters and 2 hydroxides. And of course I could add another hydrogen ion here, the lone pair on here, form a bond with that one there, which basically now gives me 5 waters and 1 hydroxide. Okay, and then I can use another hydrogen ion over here, which will form a bond with that, which means we get that, and then I've got my 6 waters, and of course this whole thing now has a 3 plus charge. So that's it reacting with the acid. So that's one half of it. So in terms of the aluminium hydroxide, it can react with 1, 2, 3 hydrogen ions to form the 6 waters again, giving you the aqueous ion up here. If I just go back to kind of where we were with the hydroxide, okay, just get rid of that, get rid of that, get rid of that. So just go back to where we were. So again, we've got aluminium hydroxide, which, let's put that one back in there, which has got 3 waters circled in red and 3 hydroxides here. It's feasible basically that another hydroxide here can react with 1 more hydrogen off one of the waters to form water, which means all of that goes. And if you look at what we've got now, we've now got 4 hydroxides. So what we've got in this one, if I write the formula out for this at the bottom down here, I've now got aluminium with 2 waters and 4 hydroxides. Now if you remember, the aluminium has a 3 plus charge here, these have 1 minus each, and there are 4 of them, so the overall charge here is going to be 1 minus. Okay, let's get rid of those from there. So, and if you remember what we did with this, we reacted this with hydroxide. So the aluminium hydroxide, the aluminium with 3 waters and 3 hydroxides, that's kind of what we're talking about. It can react with hydrogen ions which send it back to that, and my 3 plus charge is missing off here. They should have a 3 plus charge on there. And of course that can be written this way, where we kind of show all of the waters that are surrounding it, or, which is the one that you're probably most familiar with, where it could be written like that. If we are reacting it with a base, however, one more hydroxide can remove one more hydrogen from one lot of waters to reduce the waters by 1, increase the hydroxides by 1. You've got a 1 minus charge there, and because it's charged, it now dissolves. So this white precipitate that we get of aluminium hydroxide can react with an acid to dissolve, or with a hydroxide to dissolve. And again, we can look at this one down here in terms of all of the waters that are surrounding the aluminium, or simplify it to this. So I hope that helps. Time will tell.